Alright, for our next lecture, is this a lecture? I don't really know if this is a lecture. Anyways, our next thing I want to discuss, let's go with that. Okay, so our next topic of discussion is SAT strategy. Or, well, technically you have been doing strategies anyway. What we're going to do now is called draw a picture, obviously. That's why it's called that. Our objective here is to utilize visualization strategies to help you improve your accuracy. Now, keep in mind, basically, this is like the fourth SAT strategy I've presented you. 1 was know your vocabulary. 2 was know your basics in fractions. 3 was know your basics in decimals. And now we're looking at draw a picture. So what do I want for an example? Let's see. Well, let's go with this. I'm going to give you a little word problem here. Car A leaves, and I'm going to let it kind of go. Let's go a little faster than here. I don't like going slow. Okay. Car A leaves an intersection and drives 30 miles due north. Car B leaves an intersection, or leaves at the same time, same intersection, I guess the same time, I don't know, and drives due west. The cars stop 50 miles apart. So basically they're stopping when they're 50 miles apart. How far has car B driven from, its starting point, or from the intersection? Okay, so the question here becomes how do I get this? Well, if I start drawing this out, and let's go through this one step at a time. Okay, so here's the intersection. Car A went 30 miles due north. They went straight up. Car B is going, there's car A. Hi, I'm here. Car B is going that way, to the west. At this point, they're now 50 miles apart. That means 50 miles in a straight, as the crow flies type direction. So they're now 50 miles apart. Okay, so if you look at this, you should hopefully start to recognize that this looks like, say, a right triangle, and you could use the Pythagorean theorem of a squared plus b squared equals c squared. So 30 squared plus b squared equals 50 squared. So now, and look, at this point right here, you could actually type that into the calculator. 50 squared minus 30 squared, and you would get 1600. Then, depending on how this is presented, and personally I think you could use your answer choices. Like, if you don't know to take the square root at this point, you should recognize, okay, there's some number squared that's going to give me 1600. So you could start typing in answer choice, say blank times blank, or blank squared, which one gives me 1600. Or take the square root, and if you take the square root, you would get an answer of 40. So car B has driven 40 miles due west. Okay, let's look at another problem. You walk 5 steps south, then 3 steps east, then 3 steps south, because you're just doing something for GPS, and then finally 3 steps east again. What is the shortest, now this is the key, the shortest distance, or the number of steps, this thing's moving too slow for me. What is the shortest number of steps it would take to return to where you started? Okay, so you can kind of see me drawing it out here. Now let's actually go back for a second here. So let's follow that. Well, why am I drawing it the way I am? Okay, well, it said 5 steps south. So I picked a point, went and just drew a line going down to think south, 5. Put a 5 there. Then I go east, which means go to my right. East, 3. Then I went south again, 3. Then I went east again, 3. Now, technically, the shortest distance between those two is going literally from, say, this end point right here to this end point, straight. So, but if you continue that looks like 2 right triangles. That could be hard. But if you do this, keep in mind that they've gone all the way across. Now I've got a big right triangle. And I could tell that total, I went 6 steps east and 8 steps south. Because 5 plus 3 is 8, and 3 plus 3 is 6. Then I can use the Pythagorean theorem again, because I recognize this as a Pythagorean theorem problem, and say 6 squared plus 8 squared is 100. Take the square root of that, and you would get 10. So 10 is the least number of steps you would have to take. But Mr. Patch, not all the problems I'm going to draw will be right triangles. You're right. So let's look at another one. Let's look at one from the quiz. So from the quiz, this was from the quiz. I'm going a little ahead of myself there. A total of 81 cookies are baked for a class. 2/3 of the cookies are evenly distributed to the 27 students. How many cookies did each student receive? Did I spell receive correct? I have no clue. I always do the I before E. I think that's supposed to be E instead of I first. Oh well, too bad. I misspelled it. Let it go. Anyways, so let me think about this. Okay, so there's 81 cookies. 2/3. So when I see something like that for like a fraction, I might draw saying there's 3 groups, because that's another thing that fractions represent. When you're in elementary school, you're literally taught like that you're dividing them up into even groups. Okay, so there's 3 groups, but I'm only working with 2 of them because 2/3, kind of like a duck. So if I do that and divide by 3, I would find out that there's 27 in every group. 27, 27, 27, like that. Now that means there's 54 cookies. But here's the other part. Think about it. You've already drawn this out. If 27 students can get 1 cookie and 27 students can get another cookie, and I've drawn a circle for a cookie, guess what? Every kid gets 2 cookies. 2 cookies for everyone. And that's it. I mean, if you see that. Otherwise, you would have been saying, okay, well, 54, I have 54 total cookies that are left to be distributed to the kids. So if I divide those up, the 54 divided by 27, guess what you end up with? 2 cookies. So there's different ways we can approach a problem, and sometimes if you draw it out, you'll see it. Now we're going to practice this over a couple of days, so kind of keep that in mind. We'll practice it maybe even going over the quiz questions and some other problems, and expect to do some of this in class in front of other people. Don't worry, you'll be fine. Okay? Anyways, thank you very much. I hope y'all have had a good weekend, and you'll see this soon. Thank you.